early Mars may not have been quite the warm, wet paradise scientists have hoped for, not if the valleys scouring its surface work the same way as their counterparts here on Earth do. That's the conclusion of new research that tried to suss out what the red planet really looked like during its first billion years by analyzing more than 10,000 segments of valleys on Mars. According to the new analysis, some Martian valleys may have been formed by a similar process to those lurking below Devon Island's ice in the Canadian Arctic. Devon Island is one of the best analogues we have for Mars here on Earth, said Osinski, a co-author in the study. It is a cold, dry polar desert, and we know the glaciation is largely cold-based. To reach this conclusion, lead author Anna Gallofrey, former PhD student in the Department of Earth Science and Atmospheric Sciences, developed and used new technique to examine thousands of Martian valleys. She and her co-authors also compared the Martian valleys to the subglacial channels in the Canadian Arctic Islands and uncovered striking similarities. For the last 40 years, since Mars's valleys were first discovered, the assumption was that the rivers once flowed on Mars, eroding and originating all of these valleys. But there are hundreds of valleys on Mars, and they look very different from each other. If we look at Earth from a satellite, we can see a lot of valleys, some of them made by rivers, some made by glaciers, some made by other processes, and each type has a distinctive shape. And one of those processes, the researchers say, could be meltwater flowing between an ice sheet and the ground below it. That sort of erosion produces a different valley pattern than one generated by a free-flowing river. And many of the Martian valleys they studied seem to be a better match for that ice sheet formation model. In total, the researchers analyzed more than 10,000 Martian valleys using a novel algorithm to infer their underlying erosion processes. These results are the first evidence for extensive subglacial erosion driven by channelized meltwater drainage beneath an ancient ice sheet on Mars. The findings demonstrate that only a fraction of valley networks match patterns typical of surface water erosion, which is in marked contrast to the conventional view. Using the geomorphology of Mars's surface to rigorously reconstruct the character and evolution of the planet in a statistical meaningful way is revolutionary. According to the analysis, 22 of the 66 networks evaluated best matched the patterns formed by meltwater running under a glacier, the researchers concluded. Another 9 best matched patterns formed by glaciers themselves, whereas 14 best matched patterns formed by rivers. Most of the rest were indistinct enough matches for a specific formation scenario. Anna Gallofrey's theory also helps explain how the valleys would have formed 3.8 billion years ago on a planet that is further away from the Sun than Earth during a time when the Sun was less intense. Climate modeling predicts that Mars's ancient climate was much cooler during the time of valley network formation. The researchers also found that the valleys that looked like they were formed by meltwater running beneath the glaciers were spread across Mars, while those that looked to have been formed by rivers were concentrated around Arabia Terra, a particularly old region of Mars according to NASA. These environments would also support better survival conditions for possible ancient life on Mars. A sheet of ice will lend more protection and stability of underlying water, as well as providing shelter from solar radiation in the absence of a magnetic field. Currently, we can reconstruct the history of global glaciation on Earth going back about 1 million to 5 million years. Anna's work will enable us to explore the advance and retreat of ice sheets back to the beginnings of Antarctica. Thank you for watching our video. Like and subscribe to our channel for more videos.